factored form of a quadratic function. So in our first example, we are looking at the zeros of a function. So if I'm thinking of the zeros of a function, what does that mean? And that means I'm going to look for the spots in this graph where it crosses the x-axis for this particular parabola. So this parabola has two x-intercepts. I'm looking for the x-intercepts, if there are any, because in this situation they are real zeros of the function, and this means the parabola crosses the x-axis at x equals -4, where x equals -4, and also where x equals 2. So just looking here, and I'm looking here, and those are the coordinates. So now it says, how do the zeros of the function relate to the factors? If I were to take those x-intercepts and make them factors, my factors of this would be x plus 4, and we could go ahead and factor it, and x minus 2. That would be if I just gave you that expression and said factor it, my factors would be x plus 4 and x minus 2. That's how they are related. Now we are going to talk about the zero product property, and what that means is for quadratic equations, if we are solving them by factoring, we have to set them equal to 0 before we can factor and solve. That's the example we just factored above, and we just had the graph. There's the factors we came up with, x minus 4 and x plus 2. We have to have that set equal to 0 before we can split up these factors and solve by saying x minus 4 equals 0, x plus 2 equals 0, and then we can solve to find our zeros, otherwise known as our x-intercepts, to equal 4 and -2, just as we saw on our graph above. Now for my next example, I want to solve this equation by factoring. The first thing I'm noticing is that it's not equal to 0. So I want to make sure it is going to be equal to 0. So I'm going to rewrite my equation as 2x squared plus 9x minus 5 equals 0. So now I'm going to factor by grouping. I'm going to multiply a times c and come up with -10. And I'm going to first list my factors of -10. This is also known as split the middle, to have 10 and -1, and then, or just 10 and 1, and then 2 and 5, and then I can figure out my signs after. So now I'm thinking of factors of 10 that are going to add or subtract to 9, and that will be my 10 and 1, and it's a 10 and -1 because 10 minus 1 equals 9. So now I'm going to rewrite my equation as 2x squared plus 10x minus 1x. This is factor by grouping or split the middle, that method, minus 5 equals 0. Good opportunity to review factoring. I'm going to group my first two terms and my last two terms. I'm now taking my greatest common factor of my first two terms, which will be 2x, and then I'll have x plus 5. Now I'm going to look at my last two terms, and I want that to be the same in parentheses, so I'm going to factor out a -1. Then I'll also have x plus 5 equals 0. So my factors of this quadratic will be 2x minus 1 and x plus 5. And that all still equals 0. Now I can split up these two factors and set them each equal to 0 in order to solve. And I'll have x plus 5 equals 0. So now I can find that x will be equal to 1/2 and x will be equal to -5. Example 3 is an application problem. And we have Marco hitting a golf ball into the air from a third level of a driving range, and we know it's 48 feet high. and they give us a function to model the golf ball, and we are looking for the time when will the ball hit the ground. Okay, so I approach application problems by sketching out something. So I'm going to sketch Marco and his golf ball. Okay, there's Marco and the golf ball. And I am looking for the time the ball is going to hit the ground. We have a parabola, and this is height in relation to time. T is time. And h of t, this is function notation, h of t is the height at any given time. At a time, I'll put. So it will give us the distance above the ground at any given time using that equation. So now I want to think about what are we looking for when the ball will hit the ground. So I'm thinking, what height will that be? And if this is 48 feet above the ground, my ground is 0 feet. So the first thing I need to do is figure out the time. I'm looking for the time when my height is 0, because 0 is my ground. And I know from before, in order to figure out how to solve quadratics, I need to set them equal to 0, which works for this problem. So now I have negative 16 t squared plus 32t plus 48. I have a couple of different options. I can graph this and I can look for my intercepts, or I can factor because I like to factor. So let's factor. I'm noticing I have a greatest common factor, and I remember I always need to take the greatest common factor first. So I'm going to factor out a negative 16. And 0 equals negative 16. When I factor that out, I have t squared minus 2t minus 3. So then what do I do with that negative 16? I can divide each side by negative 16, and I'll show you why it's going to disappear. They'll cancel out if I divide, and then 0 divided by negative 16 will be 0 equals t squared minus 2t minus 3. And now I have a quadratic I can factor. So t squared minus 2t minus 3, my factors of that will be t minus 3 and t plus 1. All of this still equals 0. Now I'm going to write below my ground here. Now when I solve for t, I'll have t minus 3 equals 0, t plus 1 equals 0. So then, now we need to solve for t, and we will have t equals 3 and t equals negative 1. We need to be careful at this point because we need to remember what the original problem was asking us to do. If we're not careful, we may circle our answers and think we're done, but the problem was asking us to determine when the ball will hit the ground. And that will happen at t equals 3 seconds, which is the answer to this problem. If I look at my other answer, it's negative 1. That would be a solution to the quadratic, but it doesn't really make sense for this problem because we can't have the golf ball hitting the ground at negative 1 seconds. So although it is an answer for t in the function, it doesn't make sense for the problem. The last example we are going to complete together today is if we're given two x-intercepts and another point a parabola passes through and we need to write an equation. So what we're going to do is first look at the x-intercepts, and that's our first step. We are going to write the factors. And what I mean by that is if I look at those two x-intercepts and I know that x equals negative 2 and x equals negative 1, I can work it backwards and think about my factors. If x equals negative 2, the factor that would have created that would be x plus 2. And the factor that would have created x equals -1 would be x plus 1. Now I say we need to solve for a. A would be the compression or the stretch. That tells us how wide or how narrow our parabola will be. So I'm going to set it up a little more formally here. Y equals, I have an A because I don't know how big that will be yet. And I'm going to put my two factors right next to that. X plus 2 and x plus 1. In order to solve for A, I need to substitute in the point I was given. I know this parabola is going to pass through -3 and 20. This is a coordinate, x and y, and that's what this is basically how I'm going to solve for A. So first, when I say solve for A, I should be just basically you're setting it up. And now I'm substituting in x and y to solve for A. So my -3 is going to substitute in for x. My 20 is going to substitute in for y, and I can solve for A. So now I have 20 equals A, and I'm just simplifying. -1 times -2. So now we'll have 20 equals 2A, A equals 10. So my last step is write my equation, and I'm going to write my equation in factored form since that's the topic of the day. And that would be y, or f of x, depending if we're writing in function notation, equals 10, parentheses, and that because we solved 10 equals a, and now I still want to write my two factors, x plus 2 and x plus 1. And that would be the equation of the parabola in factored form.